Okay, today is lesson 10.1 on sequences and patterns. So we're going to take a look at the first part. What is a sequence? Okay, a sequence is a list of numbers that follow a particular pattern. Okay, so we're looking for, we're going to have a list of numbers and there's going to be some kind of pattern we're looking for. And there are two different types of sequences. There's finite, a function that has a limited number of terms. So an example would be numbers 1, 2, 3, 4. You can see it has a beginning and an end. Okay, so finite means it's a limited number of terms. And then we have infinite, and we will identify that as a function with an unlimited number of terms, so it does not end. So you could start at 1, 2, 3, 4, and then comma, dot, 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 going on and on and on. Okay, so finite has a beginning and end. Infinite means it will go on, it has unlimited number of terms. And the last definition we would want to be familiar with is terms. They're the set of values of the sequence, also known as the range. Okay, so they're the set of values of the sequence known as the range. Those are the terms. All right, let's scroll down and fill in some information. Okay, so based on what we were told and the terms up here, we can identify this as a sequence. And what does each thing mean? Okay, so we know that the values are the range, and here are the values. So I'm going to identify this as the range. And we can say those are the terms, the term values. All right, therefore this is my domain. And that's the term numbers. Okay, and the last thing I want to label is a sub n, and it's the term number in the sequence. Okay, so for example, if I wanted to know what a sub 1, I would say it like that. This would be 2, okay? So you're using this n to act as the number there for what term I'm looking for. Okay, so for what is a sub 2, okay, I would say that this is a sub 2, the term number is 2, and my value is 4. Okay, so a sub 2 equals 4. What is the term in the sequence that is 8? So I can see here is my 8, and that is going to be when n equals 4, or you could say a sub 4. Okay, so that are the parts of a sequence and identifying the domain and range. Let's go to the next page. And we're first going to talk about recursive rules, a rule for generating terms of a sequence that depends on one or more previous terms of the sequence. Okay, so we can identify this as the value we're looking for, and this is the previous value, okay, that we can use to help us find the new value. So if I'm looking at this as my previous value, and I'm looking for the next term, term number 2, my previous value is 5, so I'm going to substitute that in and add it to 4 to get 9. Okay, so I kind of put that guy here for this spot, and then I add the 4. So again, I'm going to take the 9, the previous term, and add 4 to get 13. I add the previous term plus 4 to get 17, and so forth. All right. And this is when a sub 1 is 5. So we do have to have that first term to help us, right? We need that previous term in order to find the next terms. Okay, and that's a recursive rule. Explicit rules are different. It's a rule that can be used to find the nth term of a sequence without previous terms of a sequence. So you don't even need to have a previous term. Okay, it's going to give you a rule you can use to find the nth term without knowing anything of previous terms. Okay, we're going to use n as the number to substitute into the function. All right, so this again is the value we're finding. Oops. Okay, so it's the value we're looking for. And then we have an equation, and the n is going to be the term number. Okay, so for the next one, I'm going to substitute in 2, which will give me 0. For this one, I'm substituting in 3 for n, which will give me 4. Okay, so we're writing the next 4 terms in the table. This time I substituted in 4 for n, because that's my term number, and I get 8. And then I substitute in 5, and I get 12. Okay? Let's go to the next page, where we're going to write recursive rules. So the initial condition is a value of first term. Okay, so we need an initial condition to write a recursive rule, and then it relates to each term after the first term to the one before it. All right, so write a rule for each sequence and find the next 4 terms. Well, we know that a sub 1 is 3, okay? And then we're looking to see what happens. How do we get from 3 to 8? And it looks like we added 5. And then from 8 to 13, yes, we are adding 5. So we can write the rule that the value I'm looking for, a sub n, will be the term, okay, the previous term, plus 5. All right, so if I have 23, I can say a sub, what am I looking for? 1, 2, 3, 4, 5, a sub 6, okay, will give me 23, I'm substituting my previous term, plus 5. And that will give me 28. Okay, and then from there I know I'm adding 5 to get 33, add 5 to get 38, and then add 5 to get 43. All right, that's for a recursive rule. Let's look at the next one. How did I get from -1 to -2, to positive 2 to -4? So I'm not really adding because I'm seeing that I'm switching from negative to positive, so it looks like I'm doing a different operation. And I know that my a sub 1 is -1. Okay, so these, just like up here, we have to say this is the rule when that's the first term. So I always like to identify the first term before I write the rule. And then I say a sub n. It looks like I could be multiplying by -2, right? -2 times -1 is positive 2. Positive 2 times -2 is -4, right? So I'm multiplying by -2, multiplying by -2. So I'll write that as my rule, -2 times my previous term. Get that all clear, okay? So I can take my previous term and multiply by -2, and in this case, then I would get 32. Multiply by that by -2, I get -64. Multiply by -2, I get 128. Multiply by -2, I get -256. Okay, and that's for, again, writing recursive rules. If we're trying to write for an explicit rule, it's going to be different, right? We're basing it on, it maps a term number directly to the term value, okay? So term number to the term value. So write a rule for each sequence and find the next 4 terms. This is a little bit trickier. So I like to number the terms because we're relating it, so I like to know what each term is, well, before I find it, okay? So I do that first just to help me sort things out. And then I have to think, the number 1 is related, how did I get 5? What could I have done to 1 to get 5? And what could I have done to 2 to get 8? That would have been the same rule. And in this case, it's going to be a sub n, what I'm looking for. It's going to be 3 times the term number plus 2. And that would work for all of these. So this makes it a little trickier because you're relating the number to the term value to the term number. So there's no perfect way to figure that out. You have to kind of just use your knowledge and try to guess and check to see if it works. So in this case, I know that if I do 3 times 1 plus 2, I do get 5. 3 times 2 is 6 plus 2 is 8. 3 times 3 is 9 plus 2 is 11. So it is working. So to find the next 4 terms, I'm substituting in the term number. So let's do a sub 6 is 3 times 6 plus 2, which will give me 20. Okay. I can see that I am going up by 3, but we are trying to write an explicit rule, and that has to do with the term number. But once I can kind of write my rule, I can also then say, okay, I know I'm going up by 3, so it is easy to write from here. And we can double check. A sub 9 equals 3 times 9 plus 2. That will give me 27 plus 2, which is 29. Okay, so the rule does work, and yes, we can see we're going up by 3 in this case. Let's look at number 4. All right, so I'm again want to number these just so I know my term numbers, because I am relating the term value to the term number, so it helps me see that. And then I have to think, how did I start with 1 and how do I get to 2? All right, so 2 to 5, 3 to 10. It looks like it's going up pretty quickly, so I'm going to start thinking maybe I'm not multiplying, maybe I'm doing squaring. So if I square 1, I get 1, and I could add 1. If I square 2, I get 4, and I could add 1. Ooh, if I square 3, I get 9, and I could add 1 to get 10. So that does seem to be working. So, and I just kind of, I'm thinking like it's going up pretty quickly in numbers, so maybe I'm not multiplying or adding, and maybe I'm doing something with exponents. So I can write this as n squared plus 1. And let's do an example for 6. So if I'm looking for a sub 6, I'm going to say 6 squared plus 1, which will give me 37. Okay, and same thing, we can have a sub 7 equals 7 squared plus 1, which will give me 50, and so forth, 65 and 82. Okay, let's just do 2 more practice problems. First one we'll do recursive, so use the recursive rule to find the first 4 terms of the sequence. All right, so I know that a sub 1 is negative 26, so I'm using my previous term to find my next term. So I'm going to substitute in to find a sub 2 equals negative 26 plus 10, which will give me negative 16. And you're going to substitute in for each one. And I'm looking for the first 4 terms. So the first term is negative 26, second term is negative 16, and then if I substitute in this previous into the formula and whatnot, this is what you should get, negative 6 and 4. Okay, so you would just substitute it in again, and you would see you get negative 6. Okay, now for the explicit, again, we're relating the term to the value. Okay, and I want to know the first 4 terms, so all I have to do is substitute in the term number, which is 1. So I'm going to get, my first term will be 13. A sub 2 equals 9 plus 4 times 2. That's the term number. And I would get 17, and so forth. I'd get 21 and 25. And that is the first lesson on sequences and patterns.